got a project I'm working on. There's some videos on it. They're not put together very well. It's a 2000 Nissan Frontier that I'm putting a fuel-injected baby LT1, which is a L99, a 4.3 liter V8 fuel-injected engine into. Now, skip to the point and not have a lot of bullshit going on here. I forgot to pull the passkey module out of the car before I scrapped it after yanking the other harnesses and everything out. So I have this issue. Now, I was thinking maybe it was not in there because it was an old police car. And that is correct, kind of. The module's in there, but the wire that goes through the key and back out to measure the resistance or whatever in it, it's just looped around. It doesn't require resistance, but the module's still there. Now, according to, excuse me while I look at this camera and line this up, according to this wiring diagram here, this is the loop wire that goes through the key. You can see looped around. On other diagrams, you'll see it going down to the key resistor or whatever. Now this wire right here, this dark blue, it goes all the way to the ECM to do fuel enable. Now that fuel enable wire is what tells the ECM that passkey said it's okay to start the car. It would never give me any of the service info that I was looking up. It would not give me the actual description of what that signal is, whether it was a pulse wave, on or off, 12 volts, 5 volts, ground, you know what I mean? So I'm thinking if I can just give it the signal, it's going to fire up. Now, I dug around on the internet a bit and come up with this. This is what the signal's supposed to look like based off of a running 96 Cadillac Fleetwood or something. Dude had the same question and decided to backprobe it with an oscilloscope. Here we have that. Now you can see here, over here, you have this is 5 volts on this side. That number's 5, down to 0, and then these are every 10th of a second. So here for exactly 1/10 of a second, you have positive 5 volts, and then it goes down to 0 for 100th of a second, and then back to 5, and then back to 0 for the 100th of a second, over and over and over and over and over again, and apparently has a little bit of a tolerance as the car is running. So in other words, I need to fake this, and then fake that, and keep repeating that. Now, I kind of toy with Arduinos, but I am no programmer. I'm actually retarded, but you know, people say I'm smart because they don't touch them at all. But I was thinking there's the LED blink program, and although I don't really know how to specify frequencies of pulse width modulation signals, yada yada, nor would I know how to do that one long wave followed by the short ones. What I did do was some math and figured out the 100th of a second thing and the 10th of a second thing. And I know in Arduino you can do delay on like the LED blink program. So I know it's 1,000 units for a second. I did cross multiply, figured out that 10th of a second is 100 Arduino units that I called them. And then the 100th of a second is 10 Arduino units. See? Old school, high school math. Anyways, so I got those numbers. I decided to go in and I knew that, well, basic Arduino stuff is the setup code that you put only does it once, which is right here. I need it to only do something once, right? So I wrote, this is the setup code area. I kind of blocked it out. And then after here is my loop code. So in the setup code, I pretty much stated, hey, come on 5 volts positive, which apparently it puts out 5 volts. I was told it was 3.3. Turn on pin number 2 high, wait 1/10 of a second, turn on pin number 2 low. And then in the loop, pin number 2 low, and then delay 100th of a second. And then in the loop, I just said pin on, wait 100th, pin off, wait 100th, over, and it just repeated that over and over and over again. I only had to put it in once. And it worked magically.
Okay, now just to give you a show of the code and walk through pretty much what I remember from about all I've learned. You start up by initializing the pin you're going to use. Now you can pick any pin in here. You type INT, lowercase I, of course, and space. It should change color if you're right. Name the pin. I named it fuel enable because that's the signal I'm trying to make. The capitals do matter. And pin number 2. Always do your semicolon. And I put comments here to make sure that I know what I'm doing because I'll forget. Here's the setup function in this area. Alright. Actually down to that. Again, everything with / the computer ignores. It's just telling you what's going on for the person reading the code. It started off pin mode. It turned to fuel enable, pin number 2. I could have just said pin 2, but I called it fuel enable for simplicity. that's kind of an oxymoron, but alright, so pin mode fuel enable is an output because I'm outputting a signal. Now again, setup code, I only want to do this once. Digital write, fuel enable high. Turn the LED on. The high is the high voltage level. Give that a delay of 100, which equals a tenth of a second. And then digital write low, which turns that pin back off, delay of 10, which equals a hundredth of a second. Now it should never do that again. It should only do that once as soon as it's turned on. Now here it's going to repeat these two lines over and over and over again. Write it on, give it a hundredth of a second, turn it off, give it a hundredth of a second, write it on, hundredth of a second, turn it off, hundredth of a second. So it really seemed pretty simple, honestly. I'd spend a lot of time trying to figure out how to do frequencies and stuff until I had the better idea. So upload it to your board and I'll show you it working. Okay, so here's my oscilloscope, DSO 138, excuse me, DSO 138. To build your own oscilloscope kit, I 3D printed the case. It's like 14, 20 bucks or something like that, but works pretty well. I got it set to 2 volts to like 10 volts or something like that. Well, I don't know what the 2 volts mean. I think it's every 2 volts for every block. But this dot here is your 5 volt marker. This dot's your 0 volt marker. I'm reading it every 50 milliseconds. Alright, and I've got it hooked up to the Arduino. This one going to pin 2. This one going to ground. As you can see here, pin number 2. And then that wires on one of the ground pins. My power supply is through this USB cord going to my little USB power block. Alright, now it's currently off. Just remember this thing here, we need to see that happen for a split second, a tenth of a second, and then all of these for a hundredth of a second. Now, watch the genius unfold. That's whatever. Ready? On. And then it just keeps going. It's so beautiful. Off. Back on. Now if you go and change the time, it moves a little slower, so sometimes it don't really catch that first wave, but yeah, 50 milliseconds is about as fast as you gotta get to catch it. Boom. So hopefully this is going to work. I haven't installed it yet, but I'm pretty much going to run. I'm pretty sure you can run 12 volts into this. I'm going to make sure, but the voltage input right there, it should be able to step it down to the 5 volts that it needs. So I'm going to run the 12 volt ignition on power there and have this run to my blue fuel enable signal. I'll probably get a code for no communication with the passkey, but in theory, it's as long as it's getting that signal. It is a communication, right? I don't know. Maybe I won't get a code. We'll see.